Let's start with the seventh video. First topic: oscillation of a liquid in a U-tube. Now consider a U-tube. This is a U-tube which doesn't look like a U-tube. Consider that a U-tube of uniform cross-sectional area alpha. We pour a liquid of density rho into this tube. At the first instant, the liquid will be present in the tube at the same height from below in both the limbs. But to start oscillation in this liquid, what we can do, we can force air through our mouth into one of the limbs. So the level of the liquid in one limb will get depressed if we force in air through our mouth, and the liquid level rises to the same height in the other limb, because the cross sectional area is uniform for both the limbs. Now the length of liquid in the two limbs at the beginning, if we take this height to be L. Now we try to find out first the mass of liquid in the U-tube. Total mass of liquid in the U-tube. Now what is mass? Mass means volume into density. Now the volume is given by 2L is the length, and the area of cross section is alpha into density. So 2L alpha rho gives the mass of the liquid column, total mass of the liquid in the two columns. Now if the liquid in one limb is depressed by x, suppose the liquid level is depressed by a distance x, so in this limb it will rise a distance x. Depression of x leads to an increase of height of x in the opposite limb. Now the difference in the height of the liquid levels in the two limbs. What is the difference of height in the two limbs? X plus x. So if we draw an imaginary line here, the difference between these two lines is 2x. So the difference in the height of the liquid in both the limbs becomes 2x. Difference in height of liquid in two limbs equal to 2x. Weight of the liquid of height 2x is equal to, similarly weight means mass into g, so 2x is the length, alpha is the area of cross section, becomes the volume, into density becomes the mass, into g becomes the weight. So the weight, this weight, why did we find this weight of the liquid column? Now this liquid column, or rather the weight of this liquid column, provides the restoring force required to bring the liquid to the initial equilibrium. The liquid will always try to bring back itself to its initial position. So we can write the weight of liquid of height 2x is equal to the restoring force. Now what is this restoring force? I repeat, this restoring force is required to bring the liquid to its initial equilibrium. This force acts opposite to the direction of displacement x in the two limbs. This force acts in the opposite direction of displacement x in the two limbs. So restoring force, what do we write? Restoring force is equal to, with a negative sign, because it acts in an opposite direction to displacement, 2x alpha rho g. Now if we equate this with ma, force means ma, minus 2x alpha rho g, we get, instead of m we write 2l alpha rho. Already we have found out the total mass of the liquid in the two limbs, that is 2l alpha rho into acceleration is equal to minus 2x alpha rho g. From this alpha and rho gets cancelled and also 2 gets cancelled. So a is equal to minus g by l. If we compare this with A is equal to minus omega square x for simple harmonic motion, we get omega square is equal to G by L. Again, omega is equal to square root of G by L. Therefore, T is equal to 2 pi by omega equal to 2 pi root over L by G. So the time period of this motion is 2 pi root over L by G, a formula similar to that of a simple pendulum. Second topic, oscillation of a piston in a gas cylinder. So this is a piston inside a gas cylinder. The initial values of values some amount of gas is enclosed in the cylinder. The piston is frictionless. The piston is initially at C. This is the position of equilibrium. Now the pressure of the gas, initial values of pressure is P, and the length of the gas column, that means the length of this column is L. So length of the gas column is L. So the initial parameters for this oscillation are pressure P and length L. Also, we can write initial or rather equilibrium values. Now, the piston is pushed down slightly to position B. Now, suppose this be B. The piston is pushed down to this position B very slowly. Pushed down very slowly to B, position B, and then released. And then it is released. It is means the piston is released. What happens? The piston moves, or rather, the compressed gas will then expand and cause the piston to oscillate up and down. This gas, the pressure of the gas inside this cylinder increases. So the pressure inside the gas will force the piston to move up when released. So the piston will move up and down in a form of a SHM. Now, if the piston moves down through a distance x, suppose the piston moved down through a distance of x downwards from position C to B, the pressure of the enclosed gas increases from P to P dash. Sorry, P plus P. Initial pressure was P. Now the final pressure, or rather the pressure when released, the pressure when the piston was forced down, the volume of the gas decreases, the pressure increases. So the initial pressure value will now be increased by a small value, small p, and the volume decreases by small v. V was the original volume. Now the volume decreases by small v. Now if this change takes place isothermally, now what is isothermal? That means temperature will not change. Isothermal, that means the heat content will not change, or rather the heat will easily pass out, uh, and the process has to be made very slow. This process was a very slow process. So this is an isothermal. Now if the change takes place isothermally, according to Boyle's law, now isothermally means temperature is constant. We always remember, we'll discuss about these cases when we study thermodynamics. When we'll study thermodynamics, isothermal and adiabatic, all these cases will be handled there. So T is a constant for an isothermal case. So PV by T was constant. So if T is constant, then P into V varies. According to Boyle's law, it becomes PV is equal to P plus small p and V minus small v. So after multiplying this, PV plus PV minus P into small v minus small p small v. Now, as this is a small p, this is a small v, multiplication of two very small quantities leads to another very small quantity. So we can neglect this quantity. so we can neglect this quantity. Another thing is PV gets cancelled from both sides, so you can write PV is equal to capital P small p. From here we have to find out the value of small p. Small p is equal to PV by V. Now what is V? If we take the area of cross section of the limb to be alpha, so alpha into x, and for this V, or rather the volume of the whole cylinder, the length was L, so it was alpha L, so alpha gets cancelled, becomes Px by L. Now pressure into area, P into A becomes the force, so it becomes Pax by L, rather alpha, not A. Alpha is the area of cross section. Alpha P into alpha is P alpha x by L. It becomes equal to F P alpha x by L. Pressure into area becomes the force. Force again is M into A P alpha x by L. So A becomes P alpha x by Lm or ml as you write it. Let this be the capital M. Okay. So M is the mass of piston. M is the mass of the piston. P alpha x by L into M. So instead of writing this, we can write A is equal to omega square x. So comparing these two equations, we get omega square is equal to P alpha by Lm, or rather omega is equal to square root of P alpha by Lm. Now 2 pi by T alpha, here omega is equal to 2 pi by T P alpha by Lm. So T becomes equal to square root of Lm by P alpha. Now if we multiply alpha with the numerator and denominator, becomes L alpha M by P alpha square. 2 pi has been missed out. 2 pi. So 2 pi. T is equal to 2 pi root over L alpha M by P alpha square. That means 2 pi. Now what is L into alpha? L into alpha means the volume of the cylinder, M by P alpha square. We can take 1 alpha out, so we can write this in this fashion: 2 pi by alpha square root of Vm by P. The time period expression, or the expression for time period of a oscillation of a piston in a gas cylinder. Now a very important thing to understand: motion of a body in a tunnel through the center of the earth. Now if we consider the earth to be a sphere of uniform density, now this is the earth, it is considered to be a uniform sphere of density, also uniform density. Suppose rho, the value of density is rho, or we can also write the value of average density of the earth is rho. So the earth is considered as a sphere of uniform density. Now if we draw, or if we try to dig a tunnel along the diameter of this earth, suppose like this is the center of the earth. If we name this part as A and B, so let AB be a diameter of the earth. Now frictionless tunnel is imagined. Now this tunnel is a imaginary tunnel. Don't take it to be a real tunnel, imaginary tunnel, because we cannot reach the center of the earth. So to show the characteristic features of the acceleration due to gravity below the surface of the earth, such a tunnel is imagined. Now what happens when we release a mass m from this point through this tunnel? What happens when we release a mass of mass m, small m, or a body of mass small m dropped in the tunnel AB? Now after some time, if this is the center point, if we can name it as O. Let this point, okay, O. So O is the center of the earth, center of earth. So when the body reaches this point, the attraction force of the body because of the earth increases. The distance between the body and the center of the earth decreases, hence the force of attraction increases. So the body will be gaining kinetic energy tremendously. And when it reaches the center of the earth, as it has got a tremendous amount of kinetic energy, the body will not stop here. The body will move outwards again. But when the body is moving outwards, the force of attraction by the center of the earth will be acting on the body at the same time. So the body will slowly start to retard and stop at some point here. Again, the body will be moving downwards towards the center O and retracing back its motion time and again. So this will be a kind of SHM. This will be a kind of SHM, or rather an ASHM. Now, how to find the value of time period for this type of a motion? Now, first we have to find out the force of attraction. Let F be the force of attraction. That means we know what is G m by r square. So m is the mass of the earth, or rather we can take 4/3 pi. If we take the distance between this point and this point be x, so 4 pi x cube is the radius of this sphere into rho. That becomes the mass of the sphere or sphere of attraction into small m, the mass of the body of mass m here is released into the tunnel. So into m by x square. So this gives 4/3 x square and cube gets cancelled, 4/3 g pi x rho m. Now if we equate this with ma, the acceleration of the body will be equal to 4/3 g pi x rho. The value of acceleration will be 4/3 g pi x rho. Now first we can prove that whether this motion is an SHM or not. Now 4/3 is a constant, g is a constant, pi is a constant, and rho is also a constant. So we can here write a proportional to x, which is the required condition for a motion to be considered as an SHM. So a proportional to x. Now therefore the acceleration of the body is directly proportional to this distance from the center of the earth, and it is always directed towards the center of the earth because the force or the restoring force is acting always towards the mean position. Restoring force is always acting towards the mean position. Here the mean position means the center of the earth. So further we can find out the value of or rather we compare this with omega square x. Therefore omega square becomes 4/3 g pi rho, or omega is equal to square root of 4/3 g pi rho, and omega is equal to 2 pi by t. So 4/3 g pi rho. From this we can find out the value of t. That means t will be equal to 2 pi root over 3 by 4 g pi rho. So the value of t becomes this. But this value is very hard to remember. So we multiply the value of rho. That means from the previous videos, or rather if I can remember it very correctly from the first video, we had found out the value of rho, or the value of average density of the earth, which was 3g by 4 pi rg. Now if we replace the value of rho here, we can get t is equal to 2 pi 3 by 4 g pi, and instead of rho we can write 3g by 4 pi rg. So 4 pi gets cancelled, g gets cancelled, 3 gets cancelled. So it becomes 2 pi root over r by g. So the value of the time period of a body moving down an imaginary tunnel through the Earth center, through the Earth's center is 2 pi root over r by g. Now, putting the standard values of r as 6400 kilometers and g as 9.8 meter per second square, we can easily calculate the value of t. If such a tunnel can be dug, the value of t will come out to be somewhat like, if I can remember it correctly, 1 hour 24 minutes 36 seconds, sorry, 38 seconds. 1 hour 24 minutes and 38 seconds. Just by replacing the value of r and g into this equation and converting the seconds into minute, we can find that the value of time period for such a particle will be 1 hour 24 minutes and 38 seconds. So the body will move from A to B in exactly half of the above calculated time. That means one motion from A to B will be half. This is the time period, that means for A to B and back to A. This is the time taken by the particle to move from A to B and back to A. So only one motion, that means one motion means from A to B, it takes a time of t by 2. It takes a time of t by 2. So half of this time. So any body from a certain point on the Earth's surface will reach exactly the opposite end point in about 42 minutes. Now if we halve this, 60 and 24, 84, 84 half means 42 minutes. So if a body is released from a certain point on the Earth's surface, it will reach directly onto the opposite end in a span of 42 minutes. Now if the tunnel were not through the center, if the tunnel were not through the center but along a straight line joining any 2 points on the Earth's surface, the body will still have executed a simple harmonic motion of the same period and would have taken 42 minutes to reach from one end of the other. That means if we draw a tunnel like this also, not through the center but like this will also take a time of 42 minutes to reach a point from entrance to its point of exit. Time is 42 minutes.